For our final physics submission, I decided to talk about the everyday life phenomenon of inertia. The definition of inertia is a tendency to do nothing and remain unchanged. The physics definition is a property of matter by which it continues in its existing state of rest or uniform motion in a straight line, unless that state is changed by an external force. Which means, like, if you were to push a book across a table, the only thing that would stop it would be like friction. Newton's first law of motion states that an object at rest stays at rest and an object at motion stays in motion with the same speed in the same direction unless acted upon by an unbalanced force. Objects tend to keep doing the same thing they're doing because that's what their natural tendency is to do, to resist any obstacles or forces. And the tendency to resist is called inertia. Galileo developed the concept of inertia in the 17th century, reasoning that objects only stop because of friction. If you were to take a ball and roll it down a half pipe, the only difference between its initial height and its end height would be the matter of friction acting on it to not allow it to get to the same height. The smoother the surface, the less the friction. In addition to that, forces don't keep objects moving, the absence of forces do. So it's not how hard you push an object, it's how much less friction can be involved in it. A lab that we did that was based on inertia was the tablecloth trick. The goal was to swiftly remove a tablecloth from the table with dishes on it without any breaks or drastic movements in the table setting. When I did the lab, I failed a few times. I did it like 6 times and I didn't realize my mistakes until after. The dishes stayed put because of inertia. The objects were heavy enough to remain unchanged by the sudden movement of the cloth. The forces of the objects are directed downward and the tablecloth is directed outward, which is why they don't cancel out. One of the mistakes I made was not using heavy enough objects, so when I pulled the tablecloth out, the objects went flying. To change this, I added more things. I poured water in glasses, and also a big part of my success was to show how fast you move the cloth and in what direction. You have to move fast enough to eliminate the majority of the friction and at a downward pull instead of outward. So when you're pulling the tablecloth, instead of moving straight out, you kind of move down, so it goes. Adding weight really helped also, like I said, but not too much weight, because if you were to do this experiment on like a whole dining room set table, it would be really difficult to pull off. This experiment relates to many things in your daily life. Like something that would be similar would be if you were to pull out a chair from someone, and if you were to do it fast enough, the person would just fall straight to the ground instead of moving with the chair. Another thing would be, in a different sense, like if you had a shopping cart full of items and you had things on the top and you push the shopping cart against a wall, things on the top would fall off, but not things that are concealed inside the shopping cart. Another example would be the third lab we did, which was spinning a bucket overhead. There are 3 forces involved in this experiment. The water has a downward weight, and so does the gravity. The centripetal force is what causes the water to act as a solid and stay in the motion of the bucket, which is also tied in by the law of inertia. For the water to stay in a constant path of motion unless changed by an outside force, like stopping the bucket in the tracks, because if you were to stop moving, then the direction would stop the water from going this way and send it downward. And that's inertia.